Yousef? Great. Thank you, Todd. I'm Yousef Mahmoud. I have been here, this is my second year in WPI as an assistant professor. I'm going to present you a new technology that we have developed to improve the efficiency and reduce the power losses in photovoltaic PV modules. So the major goal of research and PV modules, the devices that convert sunlight into electrical energy, is to improve their energy efficiency. So this target have been tackled primarily by material science researchers to work on the material and improve their efficiency. And thankfully, every year we have some improvement, 0.5% or 1% throughout the effort of material researchers all over the world. That's good, but on the system level side, on the module level side, or PV system side, the sad news is we have sometimes energy losses that reaches 15 or 10%. And these power losses are majorly occurred by partial shading. So here we have a PV module. As you can see, a part of a PV module is shaded, maybe by a cloud, by a nearby object. And at this situation, not only the shaded part, its power is reduced, which we accept actually. The unshaded part of the PV module, its power is reduced. And sometimes 70% of the unshaded part of the PV module, its power is reduced. And overall energy losses accumulated reaches 10 to 15%, depending on the location and the shading environment the location or the PV module is installed on. So the major target of this project was to understand how these power losses are formed and to develop a new technology that can reduce or eliminate these power losses and thus increase the efficiency and improve the energy production of PV modules. So just before presenting the technology, I want to show you a little bit explanation of how these power losses appear. So if you just look of the black curve, the relationship between power output of a PV module and its operating voltage, you can see there is a voltage point at which we can get the maximum power. This is actually, it happens when all the PV module receive same irradiance. There is no shading. When we have partial shading, in this case, the power curve becomes like this. Sometimes we have 2 peaks or 3 peaks. And unfortunately, in a lot of cases, we end up operating on stuck in one of the peaks, and so the difference between this power and this power is lost. Although we have the potential here to produce 100 watt, we sometimes only produce 10 watt, which is a significant reduction in the power production of PV modules. So what's the problem? What's the solution? There have been a lot of solutions in literature in the past 10 years, but all of them relies on the principle of heuristically or trying to search the power curve periodically, and that it provides challenges and extra energy losses. So what we have provided a little bit different solution. We integrated an imaging device, a camera, optical camera, and this camera can act as an eye for the PV module. It can take continuously images for the PV module service, and from these images, from the brightness of the image at each PV cell, we can estimate how much irradiance is received by each PV cell. And ultimately, we can know exactly what is the shading, what is the intensity of the shading from the image. And this information can help us to, with the help of develop PV mathematical model, to determine exactly what is the location of the maximum power without the searching, without the scanning, eliminating all these misleading power losses. So we have built a proof of concept experiment, and we were able to successfully operate the system. Now we are in the process of developing a prototype and conduct long-term experimentation under outside real conditions to quantify and understand how much energy increase can be produced by this technology. So we have a lot of companies actually that are working on this system. So bunch of any company that are working on developing of power electronic devices, PV inverters, or just installer of PV system, as it can improve its energy. Thank you very much.